Okay, so I think we have 11 students are there. So let me will start today's lab. Okay. So first of all, what everybody need to just see in the canvas right now. The canvas, I think there is a lab experiment number one is already there. Okay. And other laboratory has been reached to lab number two, but as last lab we don't have. So we need to see for that laboratory exercise. Okay. Let me just show you stuff we have. Just a second. So let me open the canvas. Okay. So in canvas, you need to go to your DCN subject. And soon all the updated teaching scheme and evolution pattern is soon going to be updated in your canvas portal. So everybody just see those stuff. Okay. So soon you will get all the things right. So over here, you need to do the experiment number one. Okay, you need to do the experiment number one. And in the experiment number one, what you actually need to do, you can open this particular, and click on this experiment number one file. There are pre-lab, post-lab, such type of the activities also there, as you have experienced it previously in lab experiment 0. Okay. And to complete this pre-lab and post-lab and entire lab, you will get a 1 week of time. Okay, because it's required a circuit also need to create. So you need to do some of the pre-lab exercise. You can use your, you can print out and write it answer over here. It is also okay. Otherwise, you can draw it in your notebook and answer you can attach at the end also. It is also okay. So both of the stuff which is allowed over here. Okay. So you need to just complete this pre-lab exercise. Then this is a physical. There is no one in the physical. So we will go with this multi-sim task. So you need to create such multi-sim circuit. And you need to you need to draw the circuit over whatever the circuit snapshot. You need to put it over here, and the waveform that you have generated through it also you need to put it at the end. As well as at the end, you need to write a conclusion, as well as you need to do this post-lab exercise where you need to find out the answer of this question. But before going to start with this, what actually you need to take care in experiment number one. Okay, that I'm going to explain right now. Okay, I'm repeating from the beginning also. So first, that our experiment one, which is nothing but based on the sampling theorem. Okay, or we can say related to analog to digital converter, which is a initial block name as a sampling circuit. Okay, so what everybody need to do in the sampling circuit, that first we need to identify why this particular sampling theorem is required. What is Nyquist pattern? Because Nyquist word will come many times in your overall this exercise. Okay, so let me share one PPT with you. Yes, so I think this is the visible to everyone. Yeah, okay, yeah, great. So why, first of all, we required this sampling theorem, Nyquist criteria, and all the stuff. So first we need to take an example of this particular phenomena. Like whenever you observing any real life signal, like you can say temperature, let's say humidity, you can say your audio signal, you can say there are another electromagnetic wave radiation. So the signal which is in nature are mostly analog in manner. It is going to be analog signal, which is having such type of the continuous time and continuous wave, or continuous time and continuous value is going to vary. So whatever the signal that we are experiencing in a real life, that is analog signal. But whatever the signal that you are storing at your mobile phone or at your laptop or any digital gadget, which is always going to be in digital. Okay, so it will be like 1010 pattern, you need to store it over there. So now there are a biggest challenge over here that how such analog signal, how such a continuous time, continuous valued signal can be stored in terms of these ones and zeros. So to do this conversion process, we required a one device named as a analog to digital converter. Now what analog to digital converter name itself says, it will convert the sorry, it will convert analog signal into the digital signal. And it is going to convert this analog to digital basically in a 3-step. So what are the 3-step? 3-step will be a sampling, quantizing, and the encoding. Now what is sampling? Sampling is nothing but it will chopping your signal into the specific time duration. So you can see whatever the signal you are seeing over here, it is going to take a sampled value, or we can say sampled amplitude at particular interval of time. Like you have said your sampler like that after every 1 microsecond, it will take one sample. So how the sampling signal will look like? After every specific period of sequence or specific period of time, it will take a one sample from the signal. It means it will take a one, whatever the amplitude of your analog signal, it is going to assign to that sample. So that sampling theorem or sampling circuit will take a samples at a specific interval of time, or we can also say like that, chopping our signal into the vertically in a time axis. What quantization will be do? Quantization is going to be do the chopping of the signal with respect to the horizontal axis in terms of amplitude axis. And how much levels of that quantization you need to do, that's considered as a quantization level. So how much quantization level you supposed to give for your entire signal, which is depend on that what type of the encoding you are doing. So meaning of that, like what is the meaning of this quantization? Let's say whatever the sample signal you have, get it over here through the sampling. आपने जो भी यहाँ पे सैंपल सिग्नल आपने कलेक्ट किया है और whatever the sample signal you have just assigned at every particular time period, how much beat you are using to present those sample signal. आप कितने कितने बीट में वो हर एक सैंपल को रिप्रेजेंट करोगे? Okay, that is going to identify how much quantization level you're supposed to use. Meaning of that, let's say I have decided like that, whatever the sampling signal I am taking, each and every sample I am going to present with the 3 bit of the digital data. So हर एक में sample को कितने bit में present करूँगा? 3 bit में. So how many quantization level are there? That quantization level are nothing but 2�3. Whatever the bit you have decided, that's 2 of that bit, that much of the quantization level you have. So we can say there are 8 quantization level are there, and your entire signal is going to be. Hello, is it voice is coming properly, everyone? Okay. So whatever your quantization signal are there, quantization value are there, it is decided into the 10 different parts. And wherever this sample signal is going to attach to that level, that encoded value is going to that value is going to identify at the encoded block. For the better understanding, let me show you. This is the diagram. And by looking to that diagram, you will get the idea. Like ideally, what is your signal right now? Let me just draw the signal over here so you can get the idea. So ideally, your signal, it is over here, which is sample signal is this one. So green is your analog signal actually. But whatever these red samples you are seeing, which is actually the sampled value. Now, whatever this 7, 6, 5, 4, 3, 2, 1, whatever this quantization code you are seeing, it is nothing but your quantization level. So right now that quantization is going to be done with respect to the 3 bit. Have you seen there are a 3 bit is written over here? So we can say each sample is defined with respect to the 3 bit. So if 2�3 equal to 8, so that's why 0 to 7, 8 quantization level it have. So what encoding it will do? It will see that this sample is nearby to which one. So we can say this sample is nearby to, we can say that's the level 2. So what is a 2 equal to in binary? 0, 1, 0. So for this sample, your digital data is a 0, 1, 0. Likewise, this is going to be related nearby to what? We can say it's a 5. So I can say it is going to give the 5 is equal to 101. So this sample is going to convert it into digital as a 101. Likewise, it is going to identify that what is the highest value to this one. So it is going to highest value to 7. This is going to given to the highest value 7. And whatever the nearby value of that one, it's also the 7. So I can say this sample value is assigned to this voltage 7. The 7 is going to represent as a 111. So their value is going to identify as a this sample digitized into the 111. Okay. So whatever the samples are there, depend on this normalized quantized value or normalized error, depend on that, what is a nearby quantization code will be there, 0, 1, 2, 3, 4, 5, 7, which is a nearby code, and code of that 3-bit is going to present over here. Now, if it is decided like that, I am going to use a 4-bit for each sample. मैंने ऐसा डिसाइड किया कि मैं 4 बीट का हर एक सैंपल को मैं 4 बीट दूंगा. So how many quantization levels are there? Somebody please tell me. If I have decided there are a four digital data I will assign to each and every sample. So how many sample value, how many quantization levels are there? Somebody give me the answer please. यहाँ पे हर अगर मैं 3 बीट में प्रेजेंट कर रहा हूं तो यहाँ पे मेरे पास 8 क्वांटाइजेशन लेवल है. अगर मैं यहाँ पे 4 बीट में डिसाइड करता तो कितने क्वांटाइजेशन लेवल हो गए? हेलो, somebody reply me back. Am I audible?
Yes, sir. Now audible. I was.
What about other? Hello.
So can you repeat once again?
Okay, I'm saying that each sample is presented with the 3-bit. Okay, that I have decided. So over here, 8 levels are there. Each sample with the 3-bit, so 8 quantization level are there. If I choose this each sample present with the 4-bit, then how many quantization levels are there?
16.
16, because it's just like 2 raised to 4. So whatever the number of bits are there, you need to simply make a 2 raised to 4. And whatever the answer is there, that much of the quantization level you're supposed to choose. Okay. So these are the process of converting from analog signal to digital. First, you are taking a sampling. Then you deciding a quantization level. Depend on that, how much bit encoded word you are choosing. According to that, you use a quantization level. And then you are assigning each sample with the specific digital code. And your signal is going to whatever this sine wave are there or whatever this analog signal are there, actually it is converted into this bit pattern. That is the digital information of this analog one. So this is the overall analog to digital conversion process we have. Now we need to think about here, what do we mean by Nyquist criteria? So Nyquist criteria is related to the sampling only. Nyquist criteria is related to sampling only. What is Nyquist criteria? We tell us that whenever you doing a sampling of your signal, whenever you using a sampling theorem, it is always having a twice f. What do you mean by twice f? Let's say in a one particular cycle, let's take in a one particular cycle, at least a 2 sample you supposed to take. Or in another manner, you can say whatever your signal frequency, let's take your signal frequency is a 1 kilohertz. So your sample frequency at least 2 kilohertz, minimum 2 kilohertz, you must take your sampling frequency. Meaning of that, एक cycle में 2 sample तो आने ही चाहिए, compulsory. Then and then proper sampling is going to be done, and whatever the sampling data you have collected, it is possible to retrieve that sinusoidal wave or that particular wave get back whenever you convert from digital to analog. अगर आपने हर एक सैंपल हर एक साइकिल में अगर वो 1 किलोहर्ट्ज की फ्रीक्वेंसी है तो आपने अगर 2 किलोहर्ट्ज फ्रीक्वेंसी से अगर आपने सैंपलिंग किया है तो आप ओरिजिनल सिग्नल फिर से रिट्राइव कर सकते हो. If it is not satisfied, you cannot retrieve it. Let's see this example. यहाँ पे दो सैंपल है, ठीक है? This is the first sample and this is the second sample. So whenever I'll just present this sample, so approximate signal reconstructed like this one. So जब भी मैं इसका digital to analog signal convert करूँगा, so this signal I am going to retrieve it back. So from looking to that signal, I can see what is their amplitude, what is their frequency by looking to this time period. So I can say that signal shape, their original property, you can retrieve it back. Original shape you have not retrieved, but their basic property of their amplitude, frequency, phase, all of you can retrieve back. If your sampling frequency is 4f, it means there are 4 samples are there. First sample, second, third, and fourth. Okay. Then again 1, 2, 3, 4. So again you will retrieve this signal back on their original property with their amplitude and frequency and all the stuff. But if you are having a sampling frequency less, like you can say only there are one sample at a time if you are taking. So एक sample मैंने यहाँ पे लिया, दूसरा sample यहाँ पे ले रहा हूँ, तीसरा sample कहीं middle पे ले रहा हूँ. So in this 3 cycle, you see 1, 2, and 3 cycle, approximately 3 samples you are only taking. So it's always like Fs equal to F. आप ऐसा कर रहे हो कि हर एक साइकिल पे आप एक ही सैंपल ले रहे हो. सो व्हेन यू रिकंस्ट्रक्टेड दिस सिग्नल, दैट एंटायर शेप ऑफ योर सिग्नल इज टोटली गोइंग टू बी चेंज. मतलब कि जो सिग्नल आपने एनालॉग टू डिजिटल कन्वर्ट किया था वो रिट्राइव होने के टाइम ऐसा हो गया. सो मतलब कि उसकी सब प्रॉपर्टी, उसका एम्पलीट्यूड क्या था, उसकी फ्रीक्वेंसी क्या थी, कैसा वेव, दैट्स ऑल द थिंग इज गोइंग टू मिसप्लेस और इट्स ऑल द थिंग इज गोइंग टू vanish. So we can say if your sampling frequency is less than of twice of that frequency, you cannot retrieve it back. Okay. So original one, whenever you do the sampling, your sampling frequency must be at least twice of your original frequency. अगर वो 20 kilohertz का signal है या 40 kilohertz का signal है, 60 kilohertz का signal है, so sampling frequency always twice of them. At least, I am saying it's at least. So these are the thing we have, as well as there are a different type of the samples are there. Like ideal sample will be look like such type of the spikes, while we can say there are a natural sampling are there. So such type of the squared pulse are there, which is changing with respect to your amplitude. Okay, as well as there are a flat top samples are there. So there is a one specific sine square wave generator are there, but amplitude of that square wave generate is going to vary. Amplitude of that square wave generator vary depend on the analog signal you have given. So that's considered as a flat top sample. So whatever the circuit, coming back to your exercise, if you see your canvas exercise, you can get idea what now you need to do. So those who have joined late, again see this stuff. In your canvas, there is a lab experiment 1 is already given. Now you need to identify in a pre-lab exercise, like this is your sinusoidal wave and downward is your sampling pulse shape. So how the composite signal is going to created, मतलब कि आपको ये दोनों signal का multiply करके यहाँ पे नया signal draw करना है. Same thing is applicable for the B exercise only. Now there is no question 2 is just, it's written by mistake, it's a question 2. By looking to this frequency domain and the amplitude, you need to identify what is the sampling frequency. Just a second. Give me a 1 minute, okay? Give me Okay. Sorry for to wait you. So what you need to do in the second exercise, you need to identify what is the Nyquist criteria by looking to this frequency diagram, like whether Nyquist criteria having less than, greater than, or equal to that sampling frequency and a main frequency. Then after you just see this theory that what is the sampling process are there and how the sampling is going to create it. And what is this? This is actually the hardware diagram of that one. Okay, but right now, if you note over here, so we'll try to generate this stuff from this particular multisim exercise. So this a multiplier is nothing but actually generating a such type of the sample signal. So whenever you just give a AC source and some pulsated wave, both of them is going to be create a sampling signal in your terminal number A. Will generate a sampling signal in your terminal number A. While the second signal, which is a op-amp based circuit. So this op-amp based circuit is nothing but it will convert that sampled signal into again to digital. So ये portion पे like you can see at channel A your sampled output, while in B you can observe the reconstructed output. So you just see how the sample signal will look like, and whenever the signal is reconstructed back, how it is going to identify as a proper one, and try to set that. Whatever the frequency you have set in signal source and sample source, change both of the frequency. Like यहाँ पे आपने 1 kilohertz किया है, so whatever the time period of this sampler, try to change it 30 microsecond, 40 microsecond, 50, 100, 200, and see that which type of this signal you will retrieve back. So you will get the idea of your Nyquist criteria. Okay. So this exercise you need to perform in your multisim circuit. Everybody need to create this multisim circuit. Whatever the circuit you have created, you need to paste it over here. And whatever the waveform of this oscilloscope, you need to showcase in your as a next of that particular answer. And then after you need to write the answer of this post-lab exercise, depend on the Nyquist criteria and sampling theorem, as well as you need to tick mark that by performing this experiment, what outcome you have observed. What outcome you have observed in this exercise, you need to write it down, or you need to tick mark the stuff over here. Any doubt to anybody right now? Please tell me. You can see this exercise in Canvas 1. Right now it is not open because that's I have make the date something else for the others. So what I'm doing right now, let me just open it for okay. Let me just open it for today is a Friday, so there's a 6. Due date is going to be the 6, and you can see now. So everybody check their canvas. I think this is available to all of you. Okay, and if it is not visible, then let me know. But see the stuff and ask me if you have any questions. Is it okay? I need a confirmation from everyone. Yes or no? Have you guys understood? Yes or no? Please write it down in chat box. Yes, please.
Sir, I'm not getting invitation of Canvas.
You have not got any invitation from the canvas. Type your Marwadi University ID in chat box. I'm going to add you.
Okay, sir. Okay, sir.
Yeah. Type it in a chat box now. So I will add you in that one. Start doing that. If you have not finished that lab experiment 0, so finish it first, then finish the lab experiment number 1, but you need to submit it before the deadline. Okay. So how many of you have not still submitted lab experiment 0, because I have already given experiment deadline up to August 7. I've already given a 2 week of time to complete that. So is there anyone who has not submitted lab 0 yet? So tell me, otherwise start writing the answer of lab experiment 1, everyone. Okay. So are you in TC1 okay, Ranjay?
Yes, sir. Yes, sir.
Okay. Just wait for a minute. Which ID I supposed to use? Ranjay Kumar, this 92 or this 10? Ranjay?
What? What, sir?
Which ID I need to use? See your screen. Which ID I can choose? This 9200 wala
First
or
one,
ye
sir.
dusra wala? First one, okay.
Sir, first one.
Okay, check kariye apna canvas. I have sent you the invitation.
Sir, let me check.
Yeah. So guys, ask me if you have any doubt, any query. Otherwise, start submitting that lab experiment 1 and ask me if you have any query or any doubt at any point. Okay. And Ranjay, you acknowledge me, okay, once you will join with that canvas.
Yes, sir. I get notification in my Gmail.
Okay, done. Done. So start doing that. Ask me if you have any question. Yes, Parthiv. Parthiv, question, Parthiv? Hello, Parthiv. Any question? Let me show you the circuit also that I have prepared. Let me just share the circuit in a few minutes. So first, everyone's just follow the circuit that I am presenting over here. Okay. So सब लोग इस circuit को follow करिए. Once you will complete the circuit, then let me know that what is the expected output, and we will discuss on that. Okay. You can follow this circuit, and you will get a very good output from every stage. Yeah. You can change this meter also.
Not
Like in
visible.
yes. What?
Not visible.
Not visible. It is in sharing mode, my friend.
No, sir, not visible.
Visible. Let me share it. Is it now visible?
Sir, visible now.
Okay. Yeah. See. So जो आपकी लेबोरेटरी एक्सरसाइज है उसमें यहाँ पे 2 टर्मिनल वाला ओसिलोस्कोप है. ठीक है. यहाँ पे आप 3 लाइक 4 चैनल वाला ओसिलोस्कोप ले सकते हो. तो आपको पता चलेगा like from every stage, from beginning with this blue, red which is a sample signal, and green it is a reconstructed signal. So blue signal is your input signal, red signal is your sample signal, and green signal is again reconstructed signal. So you can compare all of them, like कैसा था, कैसे sample हुआ और कैसे फिर से retry हुआ. So it will be great if you can choose a 4 terminal DSO. Okay. So circuit हो जाए, बाद में मुझे बताइए कैसा output expect करना चाहिए. So we'll discuss on that. Okay. Just create the circuit as I am presenting here. Here we go.
सर आप कोई बोलना चाहते हैं?
नो नो, क्यों?
आपका माउस हिल रहा था तो मुझे लगा कि आप कुछ बोल रहे हैं, एक्सप्लेन कर रहे हैं। नहीं नहीं नहीं।
नहीं 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 नहीं, वो सेम ही है। इट इज स्टेडी, यू जस्ट नीड टू सी द स्क्रीन, और कुछ नहीं। आपको डाउट है तो आप माइक ओपन करके पूछिए, सर ये क्या है, ठीक है? बट प्रोसेस आई हैव एक्सप्लेन यू, नथिंग टू से मोर, ओके? आई एम सॉल्विंग इन डाउट इफ यू
ओके सर।
In online multisim, sampler is not there. In online multisim, you use a multiplier or digital source. Harshit,
Yes,
use
sir.
a digital source. Its name given as a sampler, but it is actually a digital source. Pulse source you can use like that. Yeah. યસ, બોલીએ બોલીએ.
સેમ્પલર કયા ગ્રુપમાં આવે છે?
સેમ્પલર ડિજિટલ
સેમ્પલર કયા
સોર્સ,
ગ્રુપમાં આવે છે?
ડિજિટલ
ઓકે સર,
સોર્સમાં,
થેન્ક યુ.
લાઈક ઓનલાઈન ઓર ઓફલાઈન?
ઓકે, ઓફલાઈન ઓફલાઈન.
સોર્સમાં જ, ડિજિટલ સોર્સ.
ઓકે.
सर डिजिटल सोर्स में नहीं है सैम्पलर.
Okay, let me show you. So you can go to the source.
सर ऑनलाइन में.
ऑनलाइन में डिजिटल सोर्स में है ही नहीं. पावर
नहीं,
सोर्स, just a second. Signal voltage source, pulse voltage you can take. On offline you can take pulse voltage from signal voltage source, pulse voltage. Okay. We will check with the online. Can somebody share the screen? Those who are doing online. Who is going to share the screen? Harshit or is asking the question? Hello.
Yes sir, sharing too. Sir, 1
Yeah,
minute, I'm sharing.
Yeah, share it. तो हर्षित, आपके पास मोबाइल लैपटॉप नहीं है? लैपटॉप पीसी कुछ भी?
सर मैकबुक है सर, उसमें मल्टीसिम ऑफलाइन नहीं चलता.
ओके, मैक में नहीं चलता. शेयर करिए ना, ऑनलाइन देख लेते हैं.
सर विजिबल है?
हाँ, विजिबल, यस. जाइए मैं, नहीं उधर नहीं, ऊपर वो सोर्स में जाइए, वो थर्ड वाला, ग्राउंड के नीचे सोर्स उसके ऊपर. इसमें देखिए पल्स होगा. ये रहा क्लॉक वोल्टेज. यू कैन टेक क्लॉक वोल्टेज. सी, यस. ठीक है. अभी उसमें सब प्रॉपर्टी होगा, राइज टाइम, फॉल टाइम, सेट करके ट्राई करें. ठीक है.
ओके सर.
What is the status, everyone? Where you have reached? Everybody type in the chat box how much you have completed, on which task you are right now, pre-lab, post-lab, circuit, lab 0. What you are doing right now. Please type it in the chat box, everyone. Also type detail also like Arsit, pre-lab completed or not, or circuit you are doing, or post-lab you are doing, likewise, okay? Everyone, I need a response from entire class. Which task you are doing, pre-lab, post-lab, circuit. Everyone must type it. What is your status, everyone? As it is as a post-lab exercise. Asit, circuit is over, or you have make it as a last. Okay, okay, okay. Neville, Abdeli, Ranjay, Aditya, Abhishek, Vineet, Harsh, Vanditu, Anand, Vivek, Bhavya, Gopal, Harsh, Kalpana, Kushi, Love. Neville has completed the circuit. We will see like if this type of the waveform you are getting or not. Everybody just verify with this one, okay? So such type of the waveform must be in your screen. Like blue color is your transmission, or you can say your actual signal. Red color signal is your sampled one. And while we can say the last one, green one, which is your reconstructed signal. Okay. I think such type of the waveform that is expected from every one of you. This is the waveform of this particular circuit. So everybody try to get it such type of the waveform. So such type of the waveform is coming for everyone or those who have completed? Is this type of the waveform are coming? Neville, can you share your screen and show me, Neville, please?
Yes, sir, sure.
Okay, Neville.
Is it visible, sir?
Still not. Now it is sharing. Okay. Now it is visible. Choose that inverse, reverse, so that white background look good. Neville, is there any way just try to explore that waveform will come as a dark one, like thick line. Just see some characteristic and is it possible with any? Just try to look that if it is. ये जो लाइन है ना वो थोड़ी ज्यादा ठीक हो ऐसा कुछ मिल रहा है आपको? Try to check that.
Okay, sir.
तो क्या तो थोड़ा अच्छे से ना हो सकता है. Let me
Zoom
also
कर
check.
बोला सर?
नहीं उसकी बात नहीं है. Output is okay. Agree with that.
Okay.
Done. You have done. But ये जो line है वो थोड़ी ठीक हो सके ऐसा कुछ आपको कहीं पे मिल रहा है सो ढूंढिए वरना it's okay. Done. I agree. Okay.
Okay, okay. Sir, can I stop sharing?
Yes, you can stop that. Done. So what's the last status, everyone? If you have any question, query, please ask me. Otherwise, you can write your enrollment number and name, then you can go. If you have any question, but make sure you complete it before given deadline. Okay? Don't and keep checking your canvas because that new details, easies, and all the stuff are updating on the canvas. So please keep checking your canvas regularly. If you're doubt, you can stay here. Otherwise, you can write your number and you can go.
और से लैब में डाउट नहीं है पर
क्या बोलिए ना.
अभी इसमें मैंने देखा तो आया था कि फर्स्ट और सेवेंथ को हॉलीडे है, तो फर्स्ट से सेवेंथ के हॉलीडे है या फर्स्ट एंड सेवेंथ पे?
फर्स्ट एंड सेवेंथ. और किसका हॉलीडे फर्स्ट एंड सेवेंथ को? मंडे.
पता नहीं, ये फर्स्ट और सेवेंथ दो लिखा था.
नहीं, ऐसा होगा, फर्स्ट को चालू होगा आपका कॉलेज, सेवेंथ को हॉलीडे होगा, ऐसा शायद.
फर्स्ट और सेवेंथ तो सैटरडे संडे है ना.
हाँ, फर्स्ट टू सेवेंथ हॉलीडे ऐसा.
हाँ,
किसने बताया ये आपको?
मारवाड़ी में वेबसाइट पोर्टल में.
आप सीसी से बात करिए ना. That's why this
Okay,
message is coming from portal. So what is the meaning? Because मुझे भी नहीं पता आप ऐसा like इतने दिनों तक छुट्टी क्यों है? I don't know. ठीक है.
ओके सर, पूछ लेता
Please ask to the CC and make it clear. Okay.
सर.
Yes. बोलिए. Okay. If you have a question, ask me. Yeah.
सर हमारी मिड सेम ऑफलाइन ही होगी.
किसमें?
मिड सेम.
DCN के? DCN का बोल रहे हो?
नहीं सर, वैसे ओवरऑल मिड सेम जो होगा हमारा.
वो शेड्यूल शेयर किया. आई थिंक वो फैकल्टी आप सीसी आपका शेड्यूल शेयर करेंगे और आपके पोर्टल में भी शायद अभी दिखाना चालू हो गया होगा व्हेन यू हैव मिड सेम एंड ऑल द स्टफ.
टाइम टेबल आ गया है पर वो नहीं पता कि ऑफलाइन या ऑनलाइन.
टाइम टेबल आ गया? कब चालू हो
हाँ,
रही है
क्या
आपकी?
मैं शेयर किया था.
हाँ
23 से सर, 23 अगस्त से.
हाँ, तो लेकिन वो जो भी इंस्ट्रक्शन होगी ना वो आपके सीसी आपके व्हाट्सएप में करेंगे, आपको मेल भी होगा और जो भी मोड ऑफ एग्जाम होगी ना वो सब शायद ऑनलाइन होनी चाहिए, बट डिटेल यू विल गेट इट फ्रॉम गाइड फ्रॉम योर CC only. Okay, don't worry about it.
ओके सर, थैंक यू.
Yeah. Okay.
ओके सर, थैंक यू सर.
Bye.